Okay, so we're looking at question 4 from this midterm 1, Math 120, winter 2016, the University of Washington's pre-calculus course. We have a balloon which begins on a platform 76 meters off the ground. And it's going to travel in such a way that its height is given by a quadratic function. So I'll have some function of time. You feed this function a particular time value. This function will spit out the height of the balloon at that given time. And we know a few things about this balloon's motion. In particular, we know that it starts at 76 meters off the ground. We know that its peak is 30 minutes. 30 minutes after departure. And we know that it hits the ground, it lands, I should say, 80 minutes after departure. And when I say lands, I mean it lands on the ground and not back on the platform. So this is given in the problem statement. I drew this picture, but all of this is given in the problem statement. And what we know about this f of t is that it is quadratic. So if you haven't already, go ahead and pause the video, see whether you can make sense of explicitly what is the function in question. What is the function that models the balloon's height at time t? So the question asks us to find that, and it also asks us to find all times during this journey when the balloon is at a height of exactly 100 meters. Okay, so let's take a look at it. What do we know about modeling quadratics, modeling parabolas? First, what sort of models do our equations take? They take one of two forms in general. Well, they take as many, whatever form we want them to. But there's two really standard forms for quadratics. One of them looks like this. And the other one looks like this. Which one we choose to use doesn't matter so much. This one is convenient to use if you happen to know the vertex of your parabola, the vertex of your quadratic. In general, you can use either one in any situation. What sort of data do we need in order to model a quadratic equation? We know that if we're trying to find a line, 2 points is sufficient to specify a specific line. It won't be a, if I tell you any 2 points, there's going to be just one line between them. With quadratics in general, we need 3 points in order to specify a parabola. So we have 1 point and we have one other point. But we need a third point. How are we going to get this third point? We have one more piece of data here. We have this fact that f of 30 is the max. And that's going to help us to generate a third point. How? Well, let's see what we're looking at here if we actually think about graphing this quadratic. We'd be graphing t versus y. Our graph would look something, based on the data we have, would look something like this, where this is 30, this is 80, and this is 76. Notice that parabolas are symmetrical. In particular, I can draw a line here. This is supposed to be the vertex. I can draw a line here, and this image mirrors perfectly nicely. So I, in fact, get 2 extra points if I want them. I get that not only is f of 80 0, but also this point, instead of 50 over this way, 50 over this way, this point here, I have that f of negative 20 is also equal to 0. And if I want it, whether it's useful or not is, well, we'll see maybe. I could also similarly mirror this point here across this line of symmetry, and I would find, well, this was 30 over in this direction, so 30 over in this direction. I have that f of 60 is also equal to 76. So now we have 4 data points, which should be plenty to go ahead and actually model the equation in question. So I'm going to go ahead and erase this for the time being. I'll bring the picture back in a little bit when we're thinking about the second part of this question. But at this point, we have some algebra to do. Which form of this equation should we use? I'm going to go ahead and use this one. You might choose to use this one, really up to you. So I like points that involve zeros. So I'm going to aim to probably use these 3 points. I think that they may just make my life a little easier. Let's see what happens when I plug these in. This equation gives me this first one. Gives me that 76 is f of 0. F of 0 is this term goes away, this term goes away. All I'm left with is this. That's quite nice. 76, this is a 6 and not a b. 76 is c. Great. I'm going to use these 2 equations as my other 2 to work with. What I have from this one, if I plug in 80 for t here, I should get 0. So what I get from equation 2 is that 0 equals 6400a plus 80b plus 76. And what I get from this one, the third one, if I plug in -20 for this, I'll again get 0. I find this is 400a minus 20b plus 76. So now I know exactly what c is. I have these 2 equations to work with in order to figure out a and b. This is a little unclear. These are 76s. These are b's. These are 6s. Maybe I can try to make those a little clearer. So you might attack this in a couple of different ways. I imagine many of your first instinct would be, oh, I can just solve for a and substitute it in the other equation. Or similarly, solve for b and substitute it in the other equation. I generally prefer to use elimination rather than substitution in situations like this. So how can I set up an elimination here? I have 80b. If I multiply this equation through by 4, then I'll have negative 80b here. So I'm going to go ahead and do that. I'm going to be somewhat brash and just do it right here rather than writing it on a line underneath. I'm multiplying through by 4. 76 times 4 is 280. This should be 304. Yeah. Now, if I combine these 2 equations, just adding, I have that 0 is equal to this and 0 is equal to this. Certainly, if I add them up, I still will have 0. So what I find then by combining these equations is 64 and 16 is 8000a. This is going to be equal to 0. This cancels out, and this turns into plus 380. So I find that a is equal to negative 380 over 8,000. Or I'll say negative 38 over 800. Maybe I'll say negative 19 over 400. And now I can solve for b by substituting it back into one of these. I'll substitute into this one. The numbers are a little bit smaller. And so I have now, here's c, and here is a. And now substituting into 3, I find 0 equals 1600 times, this is a, minus 80b plus 304. 1600 over 400 is just 4. And negative 19 times 4 is negative 76. So what I have is that 0 equals negative 76 minus 80b. This is a 6, this is a b, plus 304. If I bring 80b over here, 304 minus 76. 304 minus 80 is 224. So minus only 76 would be 228. So I find that b equals 228 over 80. And now I have the quadratic that I was looking for. I have a, I have b, I have c. I have that f of t, the entire function combining my results here. I have negative 19 over 400 t squared plus 228 over 80 t, and then plus 76. And it would be worthwhile to check that this actually works with the data points in question. I certainly do have that f of 0 equals 76. If I plug in 80